The population P of a certain city, Y years after the last census, is modeled by the equation below, where R is a constant, P naught is the population when Y equals 0. So initial population is P naught. So P equals P naught, 1 plus R to the power of Y. We're dealing with the exponential function. If during this time the population of the city decreases, so population decrease by a fixed percent each year. So that tells us that Y is in years, time in years. And the keyword is decrease. For it to be decreased, it has to be less than 1. So our base, 1 plus R, has to be less than 1. If it's equal to 1, population will not increase. If it's more than 1, then population will increase. So in that regard, we can eliminate choice C and D. C and D's are gone because if R is positive, whether it's between 0 and 1 or greater than 1, we will increase the population. So we have to narrow down to choice A and B. So yes, when you subtract 1 on both sides, R can be less than 0. But can it be less than -1? Well, let's just choose some random R. Let's say we just choose -2. R equals -2. So 1 plus -2 to the power of Y, P naught. Now, very strange things happen when you do this. So when you have -1 inside, when you happen to have odd power here, you get a negative population. Now, there's no such thing as negative population. Sure, there can be change of population that gives you negative, but population itself cannot be negative. Therefore, we cannot choose this. It has to be more than -1. Okay, that's because our R has to be, or this base has to be greater than 0, but less than, this base has to be greater than 0. So for that to be greater than 0, we can subtract 1 on both sides, then R has to be greater than -1. Okay, the correct answer is B.